Hi friends, in this video we will see the dilation, erosion, opening and closing of the morphological filtering, morphological image processing. So let's start with the dilation. So it adds pixel to the boundaries of objects in an image, and it is a process in which a binary image is expanded from its original shape. Okay, so suppose this is the image. So when we apply dilation onto this image, we will get like something like this. So this is used to expand the shape of the image, and we represent dilation by using the XOR symbol. Here F XOR H of S means here F is image, H is structuring element, is equal to max of F of X plus H of S minus X. We will use this. We will make use of this equation to solve the question. And now erosion, it is exactly opposite to the dilation. It reduces the pixel from object boundary. It adds a pixel to object boundary, but it reduces the pixel from object boundary. Now second is, it is the process in which image is shrinks from its original shape. So suppose this is image, then when we apply erosion to this image, we will get this image. The shape of this will be shrink, and we represent erosion by this XNOR symbol. Here F is image, H is structuring element, is equal to minimum of F of S plus X minus H of X. So we will see this in solving the equation. Okay, and now see the opening and closing. So opening is erosion followed by dilation. So it is represented by this symbol. So it is erosion followed by dilation. So A opening of B will be equal to, here we will have first erosion and then we will do dilation. With A we will do first erosion with B and then dilation with B. But in closing we will have dilation followed by erosion. It is represented by this dot symbol. So closing of A and B will be equal to, first we will do dilation and then we will do erosion. Now we will see a question that is asked in negative previous year. Okay, so let's see the question. Let's see this question. This is asked in negative 12-13. Suppose two discrete one-dimensional functions are represented by the sequences here f 5 7 11 8 2 6 8 9 7 4 3 and h 1 2 1, and we have to compute this dilation, erosion, opening and closing. So I will give you a very simple method of finding these dilation, erosion, opening and closing. So let's start with finding of first dilation and then erosion, because we need these two to find the opening and closing. So let's start. We can see that there are 11 elements in F, so we draw 11 lines, and after that we will have the answer of dilation and erosion. So in dilation we will add and take maximum, and in erosion we will subtract and take minimum. So I will give you a very simple method of finding the dilation and erosion and opening and closing. You can follow this in your exams. Okay, so let's start. So here H is 1 2 1. So for dilation we will add them and take maximum and put that in the middle element of H. So here 1 5 plus 2 7 and 7 plus 1 8. So here maximum is 8 and we put at the place of middle, 1 to 1 middle is here, so we will put it 8. And for erosion 6 and 3 we will minus. In dilation we add and take maximum right here, and in erosion we will subtract this from this and right here at the middle. So for erosion 5 minus 2 3, 7 minus 1 6, so the minimum is 3, and then we shift it by one place, and again we will add or subtract this element by this, the original f. Okay, so we will not consider this again. So for this 5 plus 1 6, this is 9 and this is 12, so the maximum is 12, we write at the middle 12. And for erosion 5 minus 1 4, here 5, here 10, so the minimum is 4. Now again we shift and we will not make use of this again. Here 8, 13 and 9, so maximum is 13 here, and when we subtract 6, 9 and 7, so the minimum is 6. Again we shift it by 1. Here 12, 10 and 3, so the maximum is 12, and when we subtract here 10, 6 and 1, so 1 is minimum. Again we shift it, and don't write this cut marks in exams, I just use for explanation. So here 8 plus 1 9, 4 and 7, so the maximum is 9, and then 8 minus 1 7, 0 and 5, so minimum is 0. Again we shift it, 3, 8 and 9, so we will write 9, and minimum 1, 4 and 7, so 1. Again we shift it, 7, 10 and 10, so here we will have 10, and 5, 6 and 8, then 5 is minimum. Again we shift it, 9, 11 and 8, so 11 is maximum, and 7, 7 and 6, so 6 is minimum. Again we shift this, then here 10, 9 and 5, so 10 is maximum, and 8, 5, 3 is minimum. Again we shift this, now say 8, 6 and 4, so 8 is maximum, and 6, 2 and 2 is minimum. Again we shift it here, so here 4 plus 1 5 and 5, so maximum is 5, and 4 minus 1 3 and 3 minus 2 1, so minimum is 1. So this is the dilation and erosion. Now we have to find the opening and closing. So we already know that the opening is first erosion and then dilation, and closing is first dilation and then erosion. Here first erosion and then dilation, here first dilation and then erosion. So to find the opening, here we will take this element f minus h, and we do the same thing with these two, then we will find the opening, and this closing if f XOR h minus h, so we will take this f XOR h and this h, and we will do the same thing, then we will have this closing. So it is very simple, I will not do this. So this is a very simple method of finding the dilation, erosion, opening and closing. Thank you friends.